I actually graphed it. Let's see if I can show it to you. See if it works.
Best way to graph it on the calculator was to get x by itself.
No, you can't. Oh, yeah, maybe you can. I didn't do that way though.
Yeah, if you do that, then you can graph it. Then the calculator can do the rest.
Oh, I had it. Why aren't you working for me? There it is. All right. Okay, how come I don't see it? So this is the graph of it, and you can see it's not a function, right? But you can see that right here, there's could be a tangent line we put through there, correct? And the tangent line, I'll show you how I came up with it in a bit. Is right there, okay? So how do you get that 1/3? Well, we're gonna do that implicitly, okay? But you can see you can get some really crazy curves, and Dismos allows you to do that, all right?
And I don't know how you got that, but okay.
How did I got that curve?
Know how you got the tangent line.
Oh, I'm gonna show you,
Okay.
okay? All right, so you have these notes right here. And let me switch. Because you guys are just seeing this right now. All right, so let's go through the notes. Implicit differentiation. All right. On explicit differentiation, a variable is isolated. Such as y equals a negative x squared plus 2x plus 6. There's my example. An implicit equation means more than one variable on one or both sides of the equation. I'll give you some examples. Y plus x squared plus x equals 6. Or here's another one. Y plus x squared equals 6 minus x. So that's just taking this equation that's explicit and putting it in a couple of different implicit forms. Okay. So I use this term taking a derivative with respect to x. X is our input value. In other words, we pick a value for x, we plug it in, we get a y, correct? It's our independent variable. Now, when we have an equation, what we're really doing is we're taking the derivative of every variable with respect to x. In other words, when I take the derivative of x, I am taking the derivative of x with respect to x. In other words, I could, if I wanted to, write dx over dx. But I don't, because dx over dx is saying, okay, how dx is changing, right? Dx is my run of my slope, correct? It would be the same number over itself,
Which
right?
is
The
one.
change in x over the change in x, which would be 1. But I could write that.
I don't understand why we would write, or how you got that. The dx over dx.
All I'm saying is, we're taking the derivative of x with respect to x, that will always be 1.
Okay.
So what I could say here is I could say this is really a composition. I've got a linear equation inside a quadratic. And when I take its derivative with respect to x, I can say I got 2x times the derivative of x, which is dx over dx, but that's just going to give me 2x, correct? Because dx over dx is equal to 1. Because x is changing with respect to itself the same amount, so if it changes, you know how you can have a slope of 3 over 4? Well, that means x moved over 4, correct? As y went up 3, well, I would be having 4 over 4. What is that? 1. Okay? So this could be thought as e to the 5x times 5 times dx dx, which is simply 5e to the 5x. So on this side, it's no different. I can even skip this dx over dx. Would everybody agree with that?
Okay, so 5e to the 5x.
So this is 5e to the 5x power. Now, when I take the derivative of this, you would have me write dy dx on the left-hand side, so y changed to that, and that would be on the left-hand side. On the right-hand side, you would have a negative 2x plus 2, correct? Well, so this answer would be dy over dx. I can think of it as this, that it's a composition. That inside, taking something to the first power, then I'm going to use the power rule. I'm going to have 1 times y to the 0 power, that's the power rule, times the derivative of y, which is dy over dx. This is 1, this is 1, and I get dy over dx.
Okay, just let me clear my eyes and let me.
In this case, again, I'm going to be thinking about doing the power rule here. So I'm going to have 2 times y to the first, and now I'm going to take the derivative of the y, and I'm going to have dy over dx.
So for the top one, it's dy over dx.
Correct?
For that one, dy over dx. Is the bottom one dy over dx?
This, are you saying this one right here?
Yeah, but the top one is dy over dx.
The answer here is dy over dx. The answer here is 2y times dy dx, because I have to take the derivative of this function. This is going to be e to the 5y times the derivative of 5y, which is 5. The derivative of y is dy over dx. So this is going to become 5e to the 5y times dy over dx. So anytime you see a y, you follow all your basic derivative rules and multiply at the end by dy over dx.
Okay, I'm not sure if I understand all this, but okay.
Okay, what I'm saying is if I have an expression with y in it, I apply my derivative rules. Here I applied the power rule. Here I applied the rule that says, hey, I got e to some power. I apply those rules, but then at the end of it, I multiply by dy over dx.
Okay. So what I'm saying is, if it's x, you don't put the dy over dx. If there's a y, you put the dy over dx.
Right. The reason we don't, you can write every single time dx over dx, but every single time it's going to be the number 1.
So, well, if it's respect to x, there's never going to be a dy over dx. If it's respect to y, there's always going to be a dy over dx.
Correct.
Is that the only change?
Correct.
And besides that, we basically learned nothing new today. Am I correct or no? Because I need to know so I can better understand this.
I would say yes.
Okay, so the only thing we've learned is if we're doing it with respect to different variables, we add or don't add the dy over dx.
Correct.
Is that okay?
Okay?
So I think I can understand.
So I'm going to take the derivative of this. It says, step 1, take the derivative. Each time the derivative of y is involved, include a dy over dx. So I'm going to do that. So when I take the derivative of y squared, I'm going to get 2y dy over dx. Minus, there's no y here, is there? So it's just going to be 15x squared. This is going to be 3, the derivative of y is dy over dx. Because it's really y to the first power, 1 times 3 is 3, this goes y to the 0 power, which means it becomes a 1, and because there's a y there, I have to attach the dy over dx. Okay? Everybody okay on that? Now, notice, Audrey, there's 2 of them. I can't have 2 of them. So what I do is I gather all the dy dx's on the left side. So I'm going to have 2y dy over dx minus 3 dy over dx. And then I have this term that doesn't have a dy dx. I'm going to put that on the right side. Now, why do I do that? Because I can factor out a dy and dx here and only have one of them. I have 2 right now, don't I? So I'm going to factor out the dy over the dx. And that's going to give me 2 minus 3 equals 15x squared. So now I have 1 dy over dx. And then what I'm going to do is divide both sides by 2y minus 3, and I'm going to get this expression, 15x squared over 2y minus 3. Is everybody okay with the algebra?
I think it makes sense.
What does that mean? If I want to know the slope of the tangent line on this crazy curve, I need to know both x and y to be able to plug them in. Does that make sense? Okay, so let me back up and go to this. Remember I showed you this graph? And I said there was a point 1 comma 3, correct? Okay, so if I'm going to figure out its derivative, this is going to be 3x squared. This is going to be 6y, because 2 times 3 is 6. This has an exponent of 1. Because there's a y here, I got to multiply by dy dx. This is a constant, its derivative is 0. This is going to become 3y squared. Notice I applied the power rule. There's a coefficient of 1 here. 3 times 1 is 3. I took 1 away from 2, and I'm going to have dy over dx. I have 2 dy over dx. It's 1 here and 1 here. So I'm going to rewrite this as 3x squared equals 3y squared dy over dx minus 6y dy over dx. I'm going to factor out the dy over dx, so I only have one of them. And I'm going to get, for my expression, that is going to calculate the slope of my tangent line as 3x squared over the quantity 3y squared minus 6y. This gives me my slope at any point on that crazy curve that I showed you. So now I want to know what the slope is at that point. So I'm going to put a 1 in there. And down here I'm going to put a 3. Well, this gives me 3. This gives me 3 squared is 9. 3 times 9 is 27. Minus 6 times 3 is 18. I get 27 minus 18 is 9. And I get a third. So that's how I knew that my slope of that tangent line was a third.
I was not watching. I was busy doing one of these problems.
Okay.
On the notes, I think I got it.
Okay. Does this make sense what I did here?
Take a look. Okay. So what's the part where after you factored, you got that, and then you put in 1.
Right. I told you the point. I had a particular point on the graph.
We
right?
did the thing we did before.
Right.
Like in the notes earlier, but then we just put a number in.
Correct. Correct.
Okay.
All right.
I think I got it.
Okay. So let's continue on with the notes. So let's take a look at this. Tyler, take this derivative. Okay. What's next? Equals what?
4x cubed plus 2dy.
Okay, excellent. Perfect. Okay. Ariana, next step is to do what? Okay, so this will be 3y squared dy dx, followed by what? Equals what?
4x squared plus 2.
I got 4x cubed plus 2. Is that okay?
Yeah.
Now, let's say Maria said, okay, I move this over here, right? Use the 3y squared dy dx over to the right, and you move this over to the left. Would you be wrong? No. Okay? You follow that? Okay. Alrighty. Maria, what's the next step?
You factor out the dy over dx.
And I get?
Dy over dx times 3y squared minus 2.
And that equals this, correct?
Yes.
And then are you going to tell me to divide by that quantity? Okay, I see you nod. For all the people that follow my YouTube video, she is nodding affirmatively. Bingo. That's the formula that I use to figure out slope, correct?
Okay, let's see. I did that before. Let's see. Is it? Yep, I got the same thing while you were doing the other thing. I got that.
Okay. Jonah,
Yeah.
you were gone.
Yeah.
You were in Florida. Okay. Want to take a shot on this one?
Sure.
Okay. Which side do you want to do?
I'll do the right side.
Okay. What are you going to get?
10.
10. correct. Okay? I'm going to have you guess. What do you think the first thing I should do here?
Do the chain rule.
Okay, you're going to have to do the chain rule. That's exactly correct. So what's the first thing of the chain rule you have to do?
It's f prime of g of x.
Right, so what's f?
The sine of x.
So what's the derivative of sine?
Cosine.
So it's going to be the cosine, and then you leave that by itself, correct?
Yep.
And so what do you have here? Of course, I didn't give myself enough room, so I'm going to fix this real quickly.
And I gotta get me one of those.
I gotta get one that works. There. I'm gonna write equals 10 way over here. Okay? Why did I do that? What's happening to x and y?
They're being multiplied.
So because they're being multiplied, I have to do what?
The product rule.
The product rule. So there's gonna be a big thing in here, right? With a plus in the middle?
Yep.
Okay? So, you either gotta take the derivative of x or the derivative of y. Which one do you wanna take the derivative of?
X.
What's the derivative of x?
1.
So it's gonna be 1 times y. Correct?
Yep.
Now, since you've taken the derivative of x, it's done, right?
Yep.
Now I have to take the derivative of what?
Y.
Y. Which is what?
dy over dx.
dy over dx. Now, there is only one dy dx, correct?
Yep.
So I don't have to distribute. I can divide by this right away, okay? So I'm going to write this as y plus x times dy over dx is equal to 10 over the cosine of that, correct?
Yep.
And if I wanted to, I could write this as this. 10 secant of xy. It gets me rid of that fraction rational look, correct?
Yep.
What would be my next step?
Minus y.
Minus y. So I'm going to have 10 secant of that thing minus y. And then what's the last thing I'm going to do?
Divide by x.
Yep, I think I got it.
You okay on this? I've been nervous about this all weekend.
Yeah, I can see why. It does look extremely confusing.
Yeah, when you do that. But if you kind of follow the steps, you okay?
I think I got it.
Alrighty.
Once I get the homework, we'll
Do you have a backside that looks like this? And there's a circle here, correct? And notice it says find the equation of all the tangent lines at x squared plus y squared when x equals 1. Okay? Callan, what two things do I need to make a tangent line?
The slope.
The slope is 1. What's the other thing? And the point. Does everybody understand that? Slope and point. I hark on that, don't I? Because you see that question all the time in different forms. So I'm going to find the point first. Okay? And I do that by plugging 1 in for x. Does everybody agree with that? So I'm going to have 1 squared plus y squared equals 4. That means y squared equals 3. So that means that y equals what? And I've been finding out there's a few of you that forget to do this.
I found the derivative.
And I'm going to have the square root of what? right? I gotta take the square root of both sides. The square root of what? 3. But there's also a positive 1 and a negative 1, correct? So I have 2 points, 1 comma square root of 3 and 1 negative square root of 3. In other words, here's 1, I got 1 down here, and I got 1 up here. Up here is 1 comma square root of 3, and down here is 1 negative square root of 3. I know it's not a function, correct? But it still can have tangent lines. It's going to have a tangent line that goes like this, and it's going to have a tangent line that goes like this.
Well, I wasn't watching you find the point, I found the derivative.
Okay, so what I did is I plugged in 1 into this equation.
And you square rooted it and give it plus or minus.
Right. So I'm saying there are 2 points, there better be 2 tangent lines. This one better have a positive slope, this one better have a negative slope. Okay?
But the absolute value of those
So
slopes
since
should be
he
the same.
did this, I'm gonna ask Matthew, walk me through how you took this derivative.
I did x squared, which is 2x plus
Go slow now for me.
2x
Plus,
2y dy over dx equals 0.
okay,
I subtracted-
let's just pause. Everybody see where the 0 came from? Okay, then what did you do?
I subtracted 2x, and then I divided by 2y to give me dy over dx equals a negative x over y.
Would everybody agree with that? Now, you know what I like about this? Remember before I had that square root thing? That's miserable. Isn't this nice and simple? But you need to know x and you need to know y.
Oh,
Ooh. Yeah. Okay. So, let's come up with a tangent line up here. So this is this tangent line. I'm going to have x minus 1 plus the square root of 3. There's my point that Callan said I had to have, right? So if, Callan, I plug 1 in for x and square root of 3 in for y, what's my slope?
square root of 3.
I'm going to plug 1 in for x and square root of 3 in for y. Okay, look. You see this negative symbol in here? So if I put a 1 in here, that becomes a negative what?
1.
Negative 1 over the square root of 3, because that's where the y is. And it makes sense because I have a negative slope. You can see it's slanted, so it's negative. This tangent line is going to be x minus 1 minus the square root of 3. And when I put in 1 here, I'm going to have a negative 1 over a negative square root of 3 when I put that y in here. So that becomes a positive 1 over the square root of 3. All right, everybody?
Yeah, that seems about right.
All right. Ella, which way do horizontal tangent lines go?
Horizontal.
Like this?
Yeah.
Left and right?
Yeah.
Okay. How do verticals go?
Up and down.
I've had people that didn't know that. Okay. Now, we say the slope here is undefined. Would you agree?
Yeah.
we say the slope here is what?
0.
0. How do we get 0? Can you tell me?
You put the derivative equal to 0.
No, it would be more complicated. Okay. Why is this undefined and the answer here is 0?
When it's horizontal, it's
You
straight.
know, okay, but if I look at my work, right?
Uh-huh.
What's on top here? To get 0, what has to be on top?
0.
0. Would everybody agree?
Mm-hmm.
What has to be on the bottom? I don't know if they ever tell you this. I don't think they do. By they, your previous teachers. They ever tell you what has to be down here?
Anything except 0.
Anything except 0. That's correct. Does everybody understand that? So the constant, there has to be a constant down here. Because 0 over 0 is not 0. That makes sense? Okay? Did really well. Okay? Over here, it's undefined. Why is it undefined?
0's on the bottom.
What's on top?
And
Anything but 0. 0 over 0 is what we call an indeterminate form. Audrey, we're actually going to figure out answers for 0 divided by 0. We do that in this class. But you got to make sure there's a number there. Okay? Now, why do I bring that up? It says find all the horizontal tangent lines of this graph. All the ones that go this way. Okay? Audrey, the only way we're going to do that is we got to take the derivative, correct? Tell me what to write.
6x plus 4, 5,
Equals? Correct? So that means dy dx is equal to what? It's going to be a fraction, right?
6x over 4y.
Will it be negative? Could I write a negative 3x over 2y? Would you be okay with that? Now, remember what Ella said. For me to have a horizontal, the top has to equal 0. The bottom cannot equal 0, correct? So I'm going to let that top equal 0. Well, that's pretty easy, Kruger. That's 0. Well, if x is 0, is y 0? No. Y is going to be the square root plus or minus the square root of 8, correct? Which is fine. I don't care, right? Everybody with me? I'm just checking.
No, I didn't know how you get the 8, but I got the x equals 0.
Okay, so I can go up here. Remember, y has to be a non-zero number.
Oh, because we put the 0 in, then we find the y.
Correct. And all I'm making sure is that y is not 0. Does everybody understand that?
Okay.
And you can see that. Boom, when I put in 0, x is gone. Well, if y's not going to be 0 to give you 16, is it? Good. Bingo. There it is. So find all the horizontal tangent lines. Now, how am I going to do that? Well, horizontal tangent lines go like this, correct? They want to know the equation for that. All lines go like this are what? What's a constant? Y is a constant, correct? So what I'm going to do is I'm going to get 2y squared equals 16. Y squared equals 8. Y is equal to plus or minus the square root of 8. So I have two horizontal tangent lines, one which is called y equals the square root of 8, and the other one which is y is equal to the negative square root of 8.
And that is the entire tangent line?
Those are the only two tangent lines that are horizontal. fact, this graph makes an ellipse, an oval. I don't know if you studied ellipses, graph. All right. Now, I'm going to do the same thing, right? It's the same equation, and already did our work. But now I'm looking for vertical. So if I go up here to where Ella said, hey, the denominator's got to be equal to 0, well, all I got to do is make 2y equal to 0. Well, that's pretty easy. Y equals 0. So they're ones that go like this, up and down. Vertical lines say not y equals 0, but what equals 0? Y, not that y equals a number, but what equals a number? X. Would you agree? So, I'm going to put 0 in for y. I'm going to get 3x squared equals 16. That means x squared equals 16 thirds. That means x is equal to plus or minus 4 over the square root of 3. I'm going to pause there. Does everybody see where the 4 magically came from? I don't think I should have to show all the steps, the square root of 16 thirds, and then break it up into 2
Yeah, I
parts.
think I get it.
So that means my 2 horizontal lines are 4 over the square root of 3 and negative 4 over the square root of 3. Are you okay with those?
I think so.
Alrighty.